Let's look at an induction problem. We're going to use mathematical induction to prove that for every positive integer n, the following is true. 1 plus 4 plus 7 plus ... 3n minus 2, that's equal to the formula n times the quantity 3n minus 1, all divided by 2. All right, the first thing we need to show here is we need to show that this formula is true for n equals 1. We know that our first term is 1, or if we plugged in a 1 here, 3 minus 2 gives us, in fact, 1. Now we've got to show that the right-hand side equals 1 by plugging in a 1 for n. So 3 times 1 is 3 minus 1 all over 2. So from this we have 1 times 2 over 2, which certainly equals 1. And that's the first step in mathematical induction. We have to show true for n equals 1. Now we're going to assume true. We're going to assume that this formula on the left and on the right is true for n equals k. And here's what that looks like. 1 plus 4 plus 7 plus ... It's going to give us 3k minus 2. And basically what we're doing is going to our formula, replacing n's with k's. And we're just going to assume this to be true. We have 3k minus 1 all over 2. Now our goal is to show true. We've got to work with this formula. In our induction assumption here, we want to show true for n equals k plus 1. Now we need to show true for n equals k plus 1. All right? So we've assumed true for n equals k. Now we need to show true for n equals k plus 1. And in essence, what we're going to do is plug this back into our formula. Let me slide this up. Go ahead and do that. Here's what our formula is going to look like. 1 plus 4 plus 7 plus ... plus 3k minus 2. That's what we assume to be true. And now we have to show that this is going to be true for k plus 1. So k plus 1 minus 2. Okay? So this is the left-hand side. That is then going to be equal to the right-hand side. We want to show that this formula is true on the right, so that we have the following: k plus 1 times the quantity 3 times k plus 1 minus 1 all over 2. So this is going to be our goal ultimately, and let me simplify that out. So we're going to have the quantity k plus 1 times 3k, and then we'll have 3 minus 1, which will give us a plus 2 all over 2. Now let's put this all together on one line. We have 1 plus 4 plus 7 plus ... plus 3k minus 2, remember that's our kth term, plus 3 times the quantity k plus 1 minus 2, and that was our k plus 1. So we assume true for n equals k. Now we have to show true for k plus 1. And in this example here, we want to end up with this. This is our goal on the right. K plus 1, the quantity, times 3k plus 2 divided by 2. So we're going to work with this left-hand side and somehow manage to come up with this value on the right. Now let's look at this part of the problem. This was our kth term, and we assume this to be true. So this was our induction assumption. We can substitute in k times 3k minus 1 all over 2 for those first groups of expressions there. And then we end up with a 3k plus 1 minus 2 to give us a 3k plus 1. So now from this we need to get a common denominator of 2. So I'll just multiply top and bottom here by 2 so that we can simplify. And so from this we get a 3k squared minus k plus 6k plus 2 all over 2. Remembering that our goal is to end up with something like this fraction on the right. So simplifying further, we end up with 3k squared plus 5k plus 2 all over 2. Now we need to factor the numerator. From this, we'll get k plus 1 times the quantity 3k plus 2 all over 2, and now we've done it. We have shown that the left-hand side is equal to our goal, and now we can say this is true by mathematical induction.